prove that there exists a linear transformation T from R square to R cube such that T of 1 comma 1 is equal to 102, T of 2 comma 3 equal to 1 minus 1 4, 1 minus 1 4. What is T of 8 comma 11? What is T of 8 comma 11? Okay. So what is the question here? What is the question? Prove that there is a linear relation between R square to R cube such that the element 1 comma 1 in R square will be mapped onto the element 102 in R cube. Similarly, the element 2 comma 3 should be mapped onto 1 minus 1 4. Okay, whatever relation you are trying to find, you must satisfy these two conditions. Okay, so like that we will prove there is going to be a relationship. That is, you are going to find what is our T equation we are going to try to find. Then using that T, you have to find what is transformation of 8 comma 11. First we complete the first one. Okay, so what is our V? What is the vector space V? R square. How will you assume the elements in R square? X comma y or A comma B. This is the second order term. Okay. Now we have to assume the standard basis from R square. What is the standard basis for R square? 1 0 0 1. Okay. There are two vectors, so we are going to assume it to be standard basis E1, E2, etc. Okay. That is the first one. Now V என்ன கொடுத்திருக்காங்கன்னு பாரு. அந்த V ஓட standard basis தான் you have to assume as the first step. Okay. So start the solution. X plus the vector 1 comma 1 and 2 comma 3. Whatever vectors is given in here R square. 1 comma 1 and 2 comma 3 as a linear combination of the standard basis express the vector 1 comma 1 and 2 comma 3 as a linear combination of the standard basis E1 equal to 1 comma 0, E2 equal to 0 comma 1. The standard basis. Okay, ma? Any doubt in this step? So what is the next step you have to do is that rewrite this given vectors. You are given two vectors, no? Rewrite this in terms of your E1 and E2. How can you write? Rewrite the given vector 1 comma 1 in terms of E1, E2. How will you write it? How can you write it? No? Whether both are same? Same or different? So, whether you can write like this 1 comma 1. Can you understand now? How? This one into this one. So what will happen? 1 into 1 will be 1. And the next one will become 0. So this one into 0 comma 1, what will happen? What is the answer you will get? 1. 0 into 1 is 0. 1 into 1 will give you 1. Is that no? So this can be written in the form of 1 comma 1 can be written as E1 plus E2. Okay, very simple logic. No? First number will be named first number 1. After the parallel vector in your standard basis 1 comma 0. For the second one 0 comma 1. For the second one in our ground, here second one le 1 comma 1. After the basis vector in add करना, इन्हें से देखना 0 comma 1. Here first place le 1 comma. आपने ये standard basis से लो 1 what you should take? 2. Okay, it should be multiplied with 1 comma 0 or 0 comma 1? 1 comma 0. So this can be written as 2e1 plus the second digit should be 3. So it should be multiplied with e1 or e2? E2. So 3e2. That's all. Okay, this is the way. First digit in cancel formula, the first place should be 1. If I need to answer in second digit means the second place should be 1. If I need to answer in third digit means the third place should be equal to 1. According to that one, you replace your e1, e2 and e2. Okay, so this is the next step. Let us express the given vectors in terms of the standard basis. Clear how to represent it? Yes, written? Okay. The next step what you are going to do is that you are going to apply our t here because you already have given what is t of 1 comma 1 and t of 2 comma 3. So you are going to apply our t over this equation. You are going to solve this and you are going to find what is t of e1 and what is t of e2. Okay, what is the next step you are going to do? So write next line. Applying the linear transform. Applying the linear transformation t. Applying the linear transformation t on both sides. On both sides. நீங்க டிஃபரன்ஷியல் ஆபரேட்டர் மற்ற ஆபரேட்டர் அப்ளை பண்ணீங்களா அதே லாஜிக் apply the operator t throughout the equation. So what happened to the first equation? T of 1 comma 1 is equal to, so you have to apply the transformation here now. It is linear, so what you can do? Linear means what you can do? 1 into e1. You will apply the operator t for which one? E1, because e1 e2 are our vectors. What about 1, 2, 3? Scalars. So scalars can be taken outside the linear operator. So this equation 1 can be written as t of e1 plus t of e2. Applying the transformation. The constant can be taken outside the operator since it is linear. But in your question, you are given what is t of 1 comma 1. What is 1 comma 1? 1 0 2. So right? So that implies transformation of e1 plus transformation of e2 equal to the vector 1 0 2. According to the given transformation. Take it as equation number 1. In the statement, you are given this mapping. So we replace it. Similarly, write another equation. Apply the transformation. T of 2 comma 3 equal to 2 into t of e1 plus 3 into t of e2. Applying the operator t on both sides. But what is the LHS? 1 minus 1 and 4. Replace it. So 2 into transformation of e1 plus 3 into transformation of e2 equal to 1 minus 1 4. Take it as equation number 2. Now what is the next step you have to do is that having two unknowns and two equations. You have to solve this and you have to find what is t of e1 and t of e2. Just ordinary simultaneous solving. Okay, using that procedure you have to solve and you have to find what is t of e1, t of e2. So right, solving 1 and 2, solving 1 and 2, we get solving 1 and 2, we get t of e1 equal to 2 1 2, t of e2 equal to minus 1 minus 1 0. I am giving the solving procedure to you. It is only simultaneous solving. So now you know what is t of e1 and t of e2. What is e1 e2? They are in standard basis. Now you have got what is the transformation for the standard basis. Using this one, you are going to find what is the generalized transformation for this problem. Okay, so far what you have done, you have found the transformation for the standard basis according to the given condition. Now based on the standard basis, you are going to find the general transformation transformation equation for our given condition. Okay, so right. To find subheading, to find linear transformation. To find linear transformation. To find linear transformation. The same procedure now, but you are going to do it with some generalized variable because we are going to find a general transformation. Okay, so right. Then a1 comma a2 belongs to R square. a1 comma a2 belongs to R square. Same procedure, but we are going to do it with generalized variable. Okay, next step say write a1 a2 in terms of our standard vectors. How do you write it? Same procedure now. Write a1 a2 in terms of standard vectors as you have done here. The particular first step a1. Write this in terms of e1 e2. How do you write? See? a1 e1 plus a2 e2. That's all the same thing. That will be with integers, here we are going with the general variable. Okay, assume an element in a vector space V, generalized element, rewrite that in terms of your standard cases. Now apply the transformation on both sides. So right. So that implies transformation of a1 comma a2 equal to a1 into transformation of e1 plus a2 into transformation of e2. But you know what is transformation of e1 and transformation of e2. Replace it. So a1 into. What is transformation of e1? 2, 1, 2 plus a2 into. What is transformation of e2? Minus 1, 0. We are trying to find a generalized equation for this problem. Now simplify this one. What do you take? Add both the vectors. 2a1 minus a2, comma a1 minus a2, comma 2a1 minus 0. Just add in the corresponding vectors. So this is our linear transformation for our given problem. That's all. So using this relation only, the given elements are transformed to the elements in our RQ. You can cross verify. Okay, what is the condition given? T of 1, 1 should be equal to 1, 0, 2. So what is a1? What is a2? 1 and a2 is also 1. Replace and check whether it is an answer or not. a1 1, a2 1. So what will happen? 2 minus 1 is 1. What will happen to this one? 0. What will happen to this one? 2. Whether the given condition satisfies or not? Yes or no? This is a procedure to cross verify. Not satisfied, right? 2 into 1 is? See the original question. T of 1 comma 1 is mapped onto 1, 0, 2. And the condition is satisfied already. Satisfied or not? Similarly, you can check for transformation of 2 comma 2. Okay, this is your cross verification to check whether the answer is right or wrong. Okay, நீயே செக் பண்ணிக்கலாம். So இத ரிலேஷன் நீ சொல்லிட்டீனா என்னென்ன பேருக்கு என்ன இமேஜ் ட்ரான்ஸ்ஃபார்ம் ஆயிக்கோ அந்த எல்லாமே என்னன்னா satisfy ஆகும். Then your answer is the right one, otherwise your answer is a wrong one. Okay, where the problem is over? No, what is the second part? 8 comma 11. So right, hence transformation of 8 comma 11 is equal to. How will you find this now? How will you find transformation of 8 comma 11? A1 you have to replace A1 to be 8 and A2 to be 11. Replace and find the image because they have shown that this is the relation. So in this replace A1 equal to 8 and A2 equal to 11. Give me the answer.
5 minus 3 16.
5 minus 3 and 16. Problem is easy or not? Easy enough. As I repeatedly telling you, remember the procedures of solving the problem, not questions or answers. So tell me, what is the procedure to find the linear transformation? What is the step 1? What is the step 1? You have to rewrite the given vectors in terms of the standard basis. Okay, in the transformation there will be the vectors. You have to rewrite those vectors in terms of the standard basis. That is the step 1. What is the step 2? Apply the operator T on those equations. Solve it and find what is T of E1, T of E2, etc. Whatever is necessary. That is the step 2. Okay. What will be a step 3? You are going to identify the general relationship. Assume the variable as a generalized one like x, y or a1, a2 or b1, b2 or any other form. Rewrite that in terms of your standard basis. Apply the operator T on both the sides. Already the what is T of E1 and T of E2. Replace it, you will get the relation. This is the 3 steps you are supposed to follow. Okay? Any doubts? Tell me the steps to follow to find the linear transformation. What is the step 1? So we'll discuss some more problems based on this one, ma. Then we'll go for the next concept. Have you understood any doubt, ma? Because based on the same procedure only we are going to solve the other problems also. Similar procedures. Okay? So take the next one. Find a linear transformation. Find a linear transformation T from R cube to R cube to R cube such that T of 1 1 1 T of 1 comma 1 is equal to 1 1 1 T of 1 2 3 equal to minus 1 minus 2 3 T of 1 1 2 equal to 2 2 4. What is the question? You define the linear transformation. Okay. So what is the vector space V given? R cube. What is W? R cube. So we are going to discuss the mapping from R cube to R cube itself. How the elements will be in R cube? I am asking elements, not standard basis. X, Y, Z or A1, B1, C1. It will be a triple ordered. Okay. What is the step 1? Let us start with the solution. We will identify the corresponding standard basis. Okay. So start the solution. Express the given vectors. Express the given vectors as a linear combination. Of the standard basis as a linear combination of the standard basis. Tell me the standard basis. What is E1? 1 0 0. Always the first one should be first basis form. That is the standard basis form. What is E2? 0 1 0 and E3? 0 0 1. These are the standard basis. Right. E1 1 0 0, E2 0 1 0, E3 0 0 1. Next step, how many vectors are given in the question? 3. Rewrite all these 3 in terms of of, okay, first step is over. What is the next step you have to do? Apply the operator T on both the sides. Okay, apply the operator T. So transformation of 1, 1, 1 equal to. What happened to the RHS? Say out. T of E1, T of E2 plus T of E2. Okay. So but what is T of 1, 1, 1 is given for you? 1, 1 and 1. So get your first equation as T of E1 plus T of E2 plus T of E3 is equal to 1, 1, 1. This is the given transformation. T of 1, 1, 1 is mapped down to 1, 1, 1. Now apply for second equation. So second equation will get transformation of 1, 2, 3 equal to. Tell me the answers. T of E1 plus 2 into T of E2 plus 3 into T of E2. But what is LHS is equal to? Minus 1, minus 2 and 3. So replace it. Minus 1, minus 2, 3 equal to T of E1 plus 2 times of T of E2 plus 3 times of T of E3. Take as equation number 2. Similarly, apply for your third equation. So apply the operator T here. So T of 1, 1, 2 equal to T of E1 plus T of E2 plus 2 times of T of E2. But what is the left hand side? 2, 2 and 4. So replace it. So T of E1 plus T of E2 plus 2 times of T of E3 is equal to 2, 2 and 4. This will be our equation number 3. So 3 unknowns and 3 equations. So what is the next step you have to do? Solve. Simultaneous solving. 3 equations you don't know. How will you solve 3 equations? Sorry. Can you solve it with matrix? Right hand side is a vector. Right hand side is not a one single value. It is a representation of a vector. How can you solve it by matrix? You have to go for simultaneous. Okay, 3 equations, 3 unknowns means what you will do? You will convert them to 2 equations and 2 unknowns. Then you reduce them to 1 equation, 1 variable. Solve it and find. Then by back substitution you can find 1 by 1 variable. So here what you can do? So here directly also you can get the answer. See the equation 1 and 3. Just subtract equation 1 and 3. What happens? This is 1, this is 3. Subtract, what will happen? Now, T of E1 will get cancelled up. Whether T of E2 will get cancelled? Yes. So T of E3 minus 2 times of T of E3. What you will get? Minus T of E3. Now similarly you have to subtract your right hand side. What is the right hand side you are having? 1, 1, 1, 2, 2, 3. This is one you have to subtract. Vector subtraction. What is 1 minus 2? 1 minus 2? 1 minus 4? This is minus of. So what is T of E3? 1, 1, 3. You got 1. Similarly you can take another equation. You can try to find what is T of E1 and T of E2. Is that clear now? This is the procedure of solving. Simultaneous any way. Okay, solve it and define T of E1, E2 and E3. If you multiply by any scalar, what will happen? If this equation is multiplied by 3 for simultaneous solving, what happened to this vector? 6 and 12. Vector multiplication. So if you need to cancel, you need to multiply by 3. Multiply that in the RHS also. So what will happen? 3 into 2 will be 6, 3 into 2 will be 6, 3 into 4 will become 12. Is that clear now? have done so far? You identified the transformation of the standard basis alone. This is what you have done so far. What is the next step you have to do? Define the general transformation. For that, the same similar procedure, but you are going to apply it for a generalized variable. So what is your vector space V? R. So how will you assume a general element? X, Y, Z. Any variable you can include, whether it is A or B or X, Y, Z. Okay. Have you written after this one? Take our next step. To find linear transformation. To find linear transformation. To find linear transformation. So right, let X, Y, Z belongs to Rq. Assume an element. What is the next step you have to do? Rewrite this in terms of a standard basis. So X, Y, Z is equal to. Tell me how will you write? Same numbers panala adhe logic. First element should be X. So what should be the standard basis? A1. So X into E1 plus Y into E2 plus Z into E2. First number you need the answer mark, so compare it with the E1. Second one you need the answer, so compare with E2. In the third one you need the answer, so compare with E2. Tell me what is the next step? Yes, apply the transformation on both sides. So transformation of X, Y, Z is equal to X into transformation of E1 plus Y into transformation of E2 plus Z into transformation of E2. So now substitute what is T of E1 into E3 etc. So X into T of E1 is 4, 5, 2 plus Y into E2 is minus 4, minus 5, minus 4 plus Z into what is T of E3? 1, 1, 3. So once you simplify this vector addition, that will be a transformation. Tell me the answer. 4x minus 4y plus Z. Add all the corresponding first ones. Second one, 5x minus 5y plus Z. Third one, 2x minus 4y plus Z. Okay, so this is the linear transformation for our given problem. How will you cross verify whether it is right or wrong? We are given three relations now. When you substitute the LHS in this equation, you should get the corresponding RHS. You should be satisfied for all the three given relations. Don't check for only one or two. Check for all the three. If all the three are satisfied, then your answer is the right one, and which your answer is the wrong one. Okay, any doubt in finding the linear transformation? Any doubt, ma'am? Yes or no? Yes? Okay. So the next concept what we are going to discuss is called as the null space and range of it. Okay, range and school test discuss பண்ணிருப்பீங்க. What is range? The mapping discuss பண்ணிருப்பீங்கல 1 1 on 2. To set x and y will be given a diagram like this. The mapping will be done, which is called as a range. The set of the number of elements in the image, that is called as the range. Here also the same similar definition we are going to discuss with vector space. Okay, இங்க இருக்க எலிமெண்ட்ல இங்க போய் ஒரு மேப் ஆகுதுல, அது எல்லாத்தையும் நம்ம இமேஜ் னு சொல்லுவோம். Okay, எத்தனை number of images அந்த செட்டுக்குள்ள இருக்கோ, that is called as a range. The same similar definition we are going to define for our vector space. We are going to discuss what is our null space. We are going to discuss what is our image, that is called as the range. Then based on this one, we are going to discuss what is our dimension theorem and problems based on that one. Okay, that will be the next topic. Then there will be one more topic. With that one, our unit 4 will be over. Okay, we have discussed linear transformation now. In the last topic, we will representing the linear transformation in the form of a matrix. Okay, that will be our last topic. With that, our unit 4 will get over. Okay. Null spaces, N-U-L-L, null spaces and range. Null spaces and range. Once I start talking, you should all stop talking now. You should only listen. So right, null spaces and range. Null spaces and range. So here is the definition. Let V and W be vector space. V and W be vector space and let T from V to W be linear transformation. Linear transformation. Then the set of all vectors. X in V such that T of X is equal to 0 in W. 0 suffix W is called the null space. Or kernel. K-E-R-N-E-L. Null space or kernel of T. Null space or kernel of T. The transformation T. It is denoted by N of T. That is N of T equal to set of all X belongs to V such that T of X is equal to 0 in W. 0 indicates the corresponding 0 element. Okay. So what is the meaning of null space now? It is nothing but all the set of all elements X in V should be mapped down to which one in W? In a circle. T of X should be mapped down to what? 0 element. Okay. So X V elements enna agno it should be mapped down to 0 in W, not to any other element. Okay, not to any other non-zero element. It should be mapped down to the corresponding 0 element. Then the set of all those elements are called as the null space of T. So clear everyone? Ella null space la varum? Enda elements la null space la irukum? The image la enna varum? 0. Okay, so namoda V la nalla set of elements irukku. And the elements oda image W la enna va irukum? 0 va irukum. அப்படி இருந்ததா everything will come under the concept of our null space. Can you understand the definition now? Yes. What is the other name of null space? Kernel. Okay. Mostly we will be making use of the word as null space only, but you should remember the kernel also. Okay. Null space is the same as the kernel. It is the other name of our null space. Okay. So take the next one. Next definition. Let V and W be vector space and let T from V to W be linear transformation. Then the subset of W consisting of all images set of W consisting of all images under P of vectors in V is called range or image of T. Is called range or image of T. It is denoted by R of T. It is denoted by R of T. That is R of T equal to the set of all P of X such that X belongs to V. So can you understand the difference between null space and range now? So what is the null space? It is a set of all elements in V whose image will be 0 in our W. So all the set of elements in V will become as the null space. But what is the range? The set of images of all x's will become as the range. T of x and transformation of x. அப்படினா அதோட இமேஜ் x ஓட இமேஜ் சொல்லணும் W அதுல இருக்க எலிமெண்ட்ஸ் எல்லாம் எடுத்து போட்டுட்டது தான் நமக்கு என்னது range. So null space is defined for the vector space V, whereas the range will be defined from W. The set of all images will be in our W. And the images எடுத்து ஒரு செட்டா எடுத்தீனா that will be called as the range. Okay, can you understand the difference between both? Yes, school days la படிச்சிருப்பீங்க. Here, your image number is here. Yes. So for example, x1 is mapped onto which one? Y2. x2 is mapped onto y1 or any other sum element. Okay. So what is the y1 y2 is called as for x1? X is another image. The same logic like the vector space and also. Here instead of x and y, we say it as v and w. So these are called as the images. Okay, so this will be the elements in our V. So what will be our null space? Null space will be the set of all elements x1, x2, etc. What is the condition for that one? The image should be 0. So T of x1 should be 0. Okay, that is called as the null space. But what is the range? What is the range now? The set of all T of x. What is the image of x2? Y2. What is the image of x1? Y2. So these images will come in our range. Okay, images. The set of all images will come under the range. Can you understand it now? Okay, other concepts now we are discussing instead of x and y to be vector spaces V and W. Okay, should we proceed? Okay, now we know what is the sigma. For this we are going to define the dimension. Based on that one only we are going to define what is our dimension here. Okay, so take your next definition. Let V and W be vector spaces. Let V and W be vector spaces and T from V to W, the same sentence now. V and W be vector spaces and T from V to W be a linear transformation. If n of t and r of t, if n of t and r of t are finite dimensional, if n of t and r of t are finite dimensional, comma, then nullity of t nullity of t equal to dimension of n of t. That is the number of elements in a null space will be called as the nullity of t. Okay. Next, rank of t. That will be equal to dimension of R of t. Range. Dimension of R of t. In other words, the number of elements in R of t will be called as the rank of t. Okay. So what is nullity of t? Dimension of n of t, the null space. What is rank of t? Dimension of R of t. R of t is nothing but our range. Okay, Amma? Yes. In your problems will be questions like that. Find the nullity, rank, or find the null space, or find the range. Okay. முன்னாடி படிச்ச எல்லா டாபிக்கும் how to find the linear transformation எல்லாமே சேர்ந்து one single problem. All those topics will be combined as one single problem. Okay. Take out this one. Take out next one. Dimensional theorem. Dimensional theorem or dimensional theorem or rank nullity theorem. Dimensional theorem or rank nullity theorem. An equation connecting rank and nullity. So take down. Let statement no. Let t from E to W. Let t from E to W be a linear transformation. Be a linear transformation and be a finite dimensional. Be a finite dimensional vector space. Then dimension of R of t plus dimension of n of t is equal to dimension of v. That is, in other words, rank of t plus nullity of t is equal to dimension of t. This is called as the rank nullity theorem or dimensional theorem. Rank of t plus nullity of t is equal to dimension of t. So next we are going to discuss the problems, how to find the null space, how to identify the range, how to identify the nullity, and how to identify the rank. Okay, all this will come under the next type of problems we are going to discuss. Any doubt in the definition? No? Okay, once again recall what is null space. What is null space? All the vectors will be mapped onto 0. Okay, so the transformation of the vector should be equal to what? 0. Then those set of elements will be called as a null space. And in the logic section, we will the null space in the continue. Okay, shall we start the problem? First one. Let t from r square to r cube. Let t from r square to r cube be the linear mapping defined by t of a1, a2 t of a1, a2 equal to a1 plus a2, comma a1 minus a2, comma a2, a1 plus a2, comma a1 minus a2, comma a2. Find null space of T. First subdivision, null space of T. Second one, range of T. Second one, range of T. Okay. Have you understood the question now? Tell me what are the things you have to find? Basis and dimension. Both the things you have to find. You have to identify what is the basis for the null space and you have to find what is the dimension of the null space. Similarly, you have to find what is the basis for the range as well as the dimension for your range. What is dimension of null space is called as nullity of T. What is the dimension of range? Rank. That is the other way you have to find the corresponding nullity and rank of T. Okay, so start the solution. First one, null space of T. You are going to find for null space of T. First part. Null space of T. Where it will be called as a null space one? If the transformation is equal to 0. That is our image is equal to 0. So what is the condition for null space? T of x should be equal to 0. Here what is given? T of a1 a2. This is our transformation. This will become as a null space if this is equal to 0. Based on that logic, we can find what is a1 and a2 because we are the basis now. Okay, and the null space for any elements varundadha we kandupidikkilla irukka. Okay, what you are going to do? Equate this to 0, solve it and find what will be your a1 and a2. So that T of a1 comma a2 equal to 0 because that is the condition for null space. So that is a1 plus a2 comma a1 minus a2 comma a2 equal to 0. So in single element 0 by edutha illana what is this one ma triple ordered pair. How can I direct the right hand side? 0 comma 0 comma 0. Anyway you can write, it's your understanding one. So equate and tell me what is a1 and a2. a1 is 0, a2 is 0. From the third one directly a2 is 0. From 1 and 2 you can say that a1 also will become 0. So right, this implies a1 equal to a2 equal to 0. So right, therefore kernel of T. Kernel of what is the other name of? Null space. Which is equal to n of T is equal to. So what are the possible values for a1 a2 ma? There is only one possible value. Were there any other possibilities? No. Edana and the combination discuss panni ella possible elements irukku. But in only one possibility. What is that one? 0 and 0. So it is going to have only one set of element 0 comma 0. So the null space is having only one element which is the 0 element itself. So this is our null space. We have got our null space. And then the first part. Find the basis of the null space. That is over. What is the next one you have to find here? No. For this one itself, dimension. Dimension is called as nullity of T. Yes or no? Dimension of null space is nothing but nullity of T. So right, dimension of n of T is equal to. Tell me what is the dimension ma? How many elements kernel or null space there? Ana in one element solo kudadu. What type of element is this one? 0 element. Okay, our set la only 0 element irundaduna dimension enna 0. It is not considered as an element because it is a 0 element. 0 element vandha or element la நம்ம consider பண்ண மாட்டோம். So our set la only the 0 element மட்டுமே irundaduna its dimension will be equal to 0. It will not be considered as an element. Okay, so dimension of n of T which is nothing but nullity of T will be 0. If there is any other element means you can consider it. If it is only the 0 element means dimension will be 0 because 0 element is not considered as element because this is a previous one. And the simultaneously we will discuss from the previous solution. That is an obvious one. So the one set of solution நம்மால எடுத்துக்க முடியாது. So the dimension will be equal to 0. range of T. So for this we are going to take the help of our standard basis alone. What is our theme of vector space being here? R square. So what will be a standard basis? Standard basis, no? 1, 0 and 0, 1. So right, let the basis of R square is beta equal to 1, 0, 0, 1. Let us make the standard basis. So right, next one. Given T of A1 comma A2 is equal to, what you are trying to find is that you are going to try to find the image. The image in another okay. So T of A1 is 2. What is the relation given? A1 plus A2 comma A1 minus A2 comma A2. This is the given relation. Now what you do is that identify the transformation for the standard basis. Okay, you are given this relation. Using this one, find the transformation for the standard basis. So what is T of 1 comma 0? Others understood? What you have to do? Replace A1 as 1 and A2 as 0. Similarly, find what is T of 0 comma 1? 1 minus 1 1. A1 equal to 0, A2 equal to 1. Okay, assume the standard basis. Write the given linear transformation. Find what is the transformation for the standard basis. That's the next step. Now, what is the concept mark? So, define the image. Okay, there are many ways to find that one. According to each problem we are discussing, that method will be. Okay. Now, what you do is that rewrite this into the matrix form to identify the image. Okay, so let A is equal to 1 1 0 1 minus 1 1. நம்ம basis discuss பண்ணும்போது நம்ம ஒரு matrix concept discuss பண்ணோம் ஞாபகம் which will be called as the basis according to this matrix transformation. Number of non-zero rows. எதெல்லாம் non-zero rows இருக்கோ that will become as the basis. The same concept you are going to apply here. You are going to identify how many non-zero rows are there. Now those non-zero rows will become as the basis for our image. Okay, how can you transform this one? There is only 2 rows and 3 columns. What is the transformation you can do? With the help of the first element of first row, take the remaining first element 0. So what is the transformation? R1 will remain the same. R2 is transformed as R2 minus R2. So R1 will remain the same. 1 minus 0. Subtract 2. 1 minus 1 0. Minus 1 minus 1 1 minus 0. Any other steps possible? Any other general transformation? Possible or not possible? Not possible. Transformation பண்ணும்போது என்ன ஆகும்னா ஏற்கனவே 0 ஆன எலிமெண்ட் வந்து நான் 0 மாறக்கூடாது. அப்படி இருந்தா தான் நீ பண்ற transformationக்கு யூஸ்ஃபுல்னஸ் இருக்கு. இல்லனா இல்ல. Okay, any other transformation possible? No. So we stop up here. How many non-zero rows are there? Non-zero rows. 3 rows. Non-zero rows. So this is the first row, this is the second row. You are confused with column. How many non-zero rows are there? 2 rows. So this two will become as the basis for our image. So இதமா standard basis எடுத்து அதோட transformation apply பண்ணு. So அதோட answer matrix representation பண்ணி you reduce it to the as far as possible elements to make it as 0. So the non-zero rows in that reduced matrix will become as the basis for our image. Okay, understood? So right, next time the non-zero rows from the echelon matrix, the non-zero rows from the echelon matrix is the basis of all of T. Is the basis of all of T. Is the basis of all basis of R of T. So we have got what is the basis for the range. What is the next one you have to find? Dimension. How many elements are there in a set? No? 2. So what is the dimension? 2. So right. Therefore, dimension of R of T. It is also called what? Rank. So it is equal to rank of T. That is equal to 2. Okay. Problem question is easy or difficult? Easy one. The same concepts only everywhere we are discussing in the entire unit. Okay, 8 out.